Okay, right. Hi, and hello, YouTube. Just remind me to check on YouTube because sometimes YouTube goes away. Well, don't like it, but happens. So, as I said, we expect you to be able to use all these environments. If you're really starting with Eclipse and you really need to program, you might try IntelliJ, which is even a little easier than Eclipse, but it'll take you a while to get used to it. Look, I'm always telling stories I say too much, and I don't want to go through everything slide by slide by slide. I'm going to go quite quickly, but these are things we have to cover, and I do need to be able to fill out formats. If you stole the students about it. I know you've read about them as well, but the more you hear about them, the better. So Wednesday, I was just quickly telling you that you can add strings together, so that we can concatenate them. So I'm hoping that if this is your very first time programming, you're a little scared to see the program on Monday, but at least on Wednesday we're going through it systematically. And for now, I promise you, all the programs we write will look exactly the same. They'll start public class in the program name, and then inside there will be a public static void main, which is always the same formula. You don't even have to type it, Eclipse will fill it in for you. And then we put our commands. In fact, until about mid-April, we're not going to do anything else. We're only going to type commands in that main. And then we'll start adding more things. And in the second semester, you'll add even more. So I'm hoping that by now you've got a little used to seeing the main, and you can type your programs there. Now we have to learn about these different kinds of things we can write. So we, on our cheat sheet, let's just go back, we had way to print things on the screen. We should declare variables, because we need those to store the data that our program will process. We call those variable declarations. And we also had assignments. How do you put these things into these variables? A variable is really just a box. A variable is really just a box that you can put some value in. You have to tell Eclipse what kind of box you want. You can't put a string in an integer box. So it's very important to know what the boxes are that are available. And it's also important to know what can you put inside the box. So when we write an assignment, not like that, so you need to go back to the whole slide. When we write an assignment like C equals A plus B, C on the left-hand side is the target of our assignment. It's the box we're putting something into. It'll always just be a name for now. The right-hand side is some expression that Eclipse is going to evaluate, Java is going to evaluate, find the final value of, and it's going to put that value in the box. It's not putting A plus B in the box. Java is saying, what is A? A is 1, 2, 3, 4. What is B? B is 99. Perform the operation, add 99 to 1, 2, 3, 4, and answer 1, 2, 4, 3. And that's the value Eclipse is Java, put it in the box. Yes. What if B says, what do you want? Double B. B. Oh, double B. Oh, but you read about that. Isn't it like on page 17? Why is it an error? Oh, well, let's look quickly at the quiz. I don't care if you get through the slides or not. It's most important is that you learn something. If I can only teach you one little thing, that will be fine. Let's see if we can get to the quiz. Oh, wow, big. Single sign-on, that's my name. That's the name I got when I got to university in the early 90s. So I'm not using it to say I've got lots of money. It's just, in my year, they used to give everyone the first 4 letters of their surname as their login name. So all my friends, everyone in my year had 4-letter login names. And our student numbers were calculated differently and all kinds of beautiful things. Right. So let's have a look here at the quizzy. 1 or 2? Which was more difficult? 1. Oh. Can't I see the quiz? Oh, here we go. Okay, right. wish there was a way to get rid of some of this stuff. Okay, right. So question 1 was easy peasy. We all got that. When we ask Java to print that string on the screen, bonjour, it doesn't print the statement itself. It doesn't print the instruction. So A is not the answer. Why on earth would it translate my broken French to English? It's not going to print hello, even though that's what programming is like. I was just putting it there to see if anybody memorized whole programs and somehow recognize it. Nothing, because the program contains an error. And this is the tricky thing, because sometimes programs do contain error. And one of the things you'll learn, if you're amazed, is that you will spend the whole night working through the night, 6, 7, 8 hours, trying to find a mistake in one of your programs. And in the morning, someone will come along and quickly look at the program and say, oh yeah, that's you're missing a semicolon, or you've got something place like that. This happens all the time. And the reason is that you read what you want, what you thought you'd written. So you read what you want to do, instead of what you actually wrote. And when someone else with fresh eyes look at the program, they will spot mistakes. And this is an important skill. You have to be able to look at a program and see, oh, well, you've got a semicolon missing. Of course, it just helps by telling you where the mistake is. But this is just a skill that you will pick up and that you do need to practice also. It won't print the quotes, so E is not the answer. It'll just print bonjour le monde. Okay, right. Let's see the next page. Who speaks French? Who's a French stage student? Ah, bonjour, mademoiselle. Comment ça va? Do you say bonjour le monde or just bonjour le monde? Bonjour le monde? C'est vrai? Okay, right. Let's carry on. What was the other language? In quiz 2? Oh, no. Well, I want to stick to quiz 1. Okay, this is easy peasy. I'm not going to skip this question because we're going to run out of time. But here is the question that Mo asked us about. Right? So there's a little program. Int A is 9. So I've got an A box. It's an integer. It contains 9. Everybody happy? Okay? Good. Next line. Double B. The main box will be that you contain a double value, which is a real number, kind of a real number, and put 4 in that box. So 4.0 for integers are also real numbers. So now there's a box with integer 9 and a double 4 in it. Good. Then make another box called C that's also going to contain a double and put in it A divided by B. Okay, can I do that? A is 9, B is 4, but they're reals, so the answer will be a real. This is real division. 9 divided by 4 is 2.25, right? So it's going to be 2.25, value 2.25 in the C box. 3 boxes, A9, B4, C contains 2.25. Then it says, int D, make a box called D, it will contain an integer, and what do I put inside the integer box? A, which is 9, divided by B, which is 4.0. When I'm dividing an integer by a real number, the answer is real number. It's 2.25 again. Is 2.25 an integer? No. Can I put a non-integer in an integer box? No. Java will complain. So there's a mistake in this program. It won't compile. It doesn't compile. This is a little tricky because it involves knowing that if I have an integer that is also a real number, I can put 4 in a double box because 4 is an integer, that's true, but it's also a real number. But all real numbers like 2.25 are not integers. 2.25 is not a whole number. So I cannot put a real number inside the integer box. The 4, which is an integer, Java will convert that to the real number, to the double 4.0. But it can't convert 2.25 to an integer. And what's it supposed to do? It can't throw away the 2, 5. I mean, that's part of the number. It can write it down, but then I mustn't ask you explicitly to write down. What does it have to write up, or to the nearest integer, or just think of some other integer that's like it? No. So that's a mistake in the program and it won't compile. I think the other side was similar. So what were the options? 9. Oh no. Did you think that?
I wanted to ask about the other one.
You can answer in German.
For double. Use the remainder.
Am I making jokes for nothing? I said you can answer in German. Did you say that? People give me something to work with. It's supposed to say the answer is 9. 9. Conrad. I don't know where your name comes from, Conrad. But you come to the French name. Are you joking? 9! So you were saying 4. So 4.
Use the remainder.
Ooh, I'll ask you advanced questions. Let's get back to that in 1 minute. You can time me. 1 minute. Right. Let's just quickly go through this question, just for fun. It's not 9. That was insane. It could never be 9. Because even if this worked, even if Java somehow said, okay, 2.25, it's not an integer, but I'll put it in A in any case. So in B in any case, I'll make it 2. Let's say it's rounding down to 2. So I've got a 2 in D, and now I'm printing C minus D. C is the double 2.25. D is now the integer, but it's not really. 2.25 minus 2 is 0.25, not 9. So 9 was an insane answer. It would never be 9. That was supposed to be the misleading answer that I hope everybody targeted. It won't be 4 either, but I just threw it out there. C minus D. No, it won't print C minus D. It's going to evaluate that expression. 0. Tasty. And 0.0 and 0. But I'm afraid the right answer was G. Nothing, because the program contains an error. Now, Conrad was asking about remainder for doubles. So let's skip ahead to what we're supposed to be doing on Wednesday. These are all the operations we actually talked about them for integers. This is a little table, but you'll forget about it because you'll use it so often. The only real odd thing is that we use the percentage sign for remainder. So Conrad is asking, can I use the percentage sign for doubles? Is that what you're asking? No, you said, can one use the percentage sign for doubles?
Can one take the...
Yes, that's what I know. I'm just checking. That's what you asked. Yes, one can. If one were to be royal, one can do that. Or you can do that. Doubles have exactly the same operations as integers. So I can add them, I can subtract them, I can divide them, I can multiply them. But now we're talking about real division. So it's real addition, real subtraction, real division. And when you divide two numbers, you actually get a floating point value or some floating point. You get a real part after the decimal point, so that this number divided by 2 actually contains something after the decimal point. Odd thing is you can also do remainder, which is not usual in mathematics. In mathematics, we don't usually say that you can perform remainder on real numbers. For integers, it makes perfect sense. 5 remainder 2, well, 2 goes into 5 twice, leaves a remainder 1. That makes perfect sense. But when we're talking about real numbers, what we do is we say 3.141. I mean, that goes into 10 a certain number of times, 3 times. So if I multiply, it can't go into 10 4 times. 4 times 3 is already 12. So there's no way 3.141. Is this correct? Using a calculator? 4 times 3 is already 12. So 3.141 can't go to 10 4 times. At most 3 times. And then if I multiply that out, 3 times 3.141, and I subtract it from 10, I will get some remainder, which happens to be 0.56. So I can use numerical reals. It's a little odd. We don't really use it much, but it's not impossible. Let's just look at two other things on this slide. Firstly, there's this e to the 23 or e23, which is just engineering notation for 10 to the power of 23. So that number 6.02 e23 is really 6.02 times 10 to the power of 23. It's really a humongous number. What is that number? You all know. Say again. Don't be shy. You're probably right. I don't know. Is that anaconda constant? Or is it like a mole? I'm scared. I've never got that. Right. Coolio. Then let's look at two other odd things. You can get the square root of a number, 1.414. That's right. Okay. By writing math.sqrt and then in parentheses the number you want to take the square root of. So Java has these built-in functions that you can call, and there's a whole list on the next page. ABS, max of 2 doubles, min of 2 doubles, so the minimum and the maximum and the absolute value. And here it only says abs, max, min, but when you use them, you're supposed to write math dot. We've seen this a few times now. Well, we've seen system dot out. So sometimes there are these prefixes we add to certain commands that we give Java, and that's fine. We'll get used to them, and later on we'll discover what they really are about. This should not be too foreign to you because you've already done this at school, didn't you? Don't frown like that. I can see your frowns. I can hear all your thoughts. Did you use it at school? Really? Did you never write sign of something at school? Oh yes, that's cool. I was thinking of my other school. Right. So you did this at school, sign of something, cosine of something, tan of something. So it's not entirely foreign to us, except that now we're forced to write math.sin to sign open parentheses, something we want to take the sign of, and close parentheses. At school, we didn't have to do that. You could just write sine of theta. Everybody would be happy, but now you must put the parentheses. One mistake a few people made yesterday is to say, yeah, you know, I'm not really into semicolons. I don't think I'll leave them out. So I don't like the curly braces. They're too baroque. They're too Rococo style. I just put plain parentheses. But you can't do that at all. The computer expects you to write a brace when it's expecting a brace, and it wants you to write the parentheses and the semicolons and every other little punctuation mark. You have to be absolutely precise. So one thing you're learning, I hope, is that you have to write down what is in the book. You have to write it exactly how it's on the tutorial or in the book or on the slides, what have you. So we're not allowed to put a curly brace here. We're not allowed to put a square bracket. It must be normal round parentheses. There's one other thing about sine, cosine, and tangent is that this theta, what you're given, is not in degrees. It's in radians. Did you do radians at school? You went to two schools. The one with the sine and the other one. At the science school, did you do radians or not? What are radians? How many radians in a circle? How many degrees in a circle? That's not easy. That's not easy. How many? 360. Yes, actually. 260. Ah, right. How many radians in a circle? 2 pi. Hard, but really useful. Because the circumference of the circle is also 2 pi. Mind blown! So that if you have an angle of, let's say, 1 radian, you know that the circle formed by that angle, the length of that circle is also 1, you know. Or if you have an arc that is spanned by an angle of 2, you know that the length of the curve of that arc is also 2. So it's an amazing thing if the radius is 1. Okay. So it's really useful when you're doing mathematics, you have that. And these sine, cosine, tan, all implemented with radians. Did you learn anything else at school? Any other way of measuring angles?
Grades.
Gradients, yes. Grades.
Grades.
Gradients. How many gradients in a circle?
400.
400? No, it's only 100. So, for some reason,
There's one that's 400 as well. It's like from French. Oh, whatever. Ask the question.
Captain Sang, song. Oh, not L.
100.
Yes, song. Captain Song. Are you really fit or you sleep fit? Who is from France? Okay, just checking. No offense, your French is excellent. It's much better than mine, but I just wanted to ask a little question about the real France. In France, in the school system in France, you are scored out of 20. So all marks in primary school, in high school, at university, those marks out of 20. And in France, there is an unwritten rule that nobody ever gets 20. So the highest mark you can achieve in France is 19. When you get to 19, it counts as full marks. So it's a really odd system. That's not strictly true, but in some parts it is. Okay, let's quickly go through these, and then I have to switch to my other slide. So other things you can write is math.exp, which raises some base to some power. Math.log, which calculates logarithm. Sorry, exp does not raise some base to some power. It raises a very specific base, the natural logarithm e. 2.78, what we have. To the power a, log calculates the logarithm of a, the natural logarithm. Tau raises a to the power of b. Round, finally, something that rounds. We can round out from 2.25 by writing math.round some double value. Only tricky thing is, it doesn't send back an int, an integer. It sends back something called a log. It's really short for long integer. So a log is twice the size, twice as big as an integer. It's still a much bigger number, but for all the intents and purposes, it really is an integer. Random we'll get to soon. Square root we've seen, and there are two constants. Math of e, big E, which is the natural logarithm number, comes over this 2.787, and pi. That's really useful sometimes, especially when you need to convert from radians to degrees. We always write the same little formula that multiplies by 2 pi and divide by 360. Okay, so there's a little program, but we'll skip that for today because we really need to talk about something else entirely. Oh, but there was one thing I needed to show you. Oh, I'm so stupid. Say again? No, not the discotheque, whatever you said. Okay, I need to show you that there is one kind of real that's really odd. You may even have seen it already. If you try to take the square root of -1, which we know does not exist in real mathematics. The complex mathematics does, but in real math, when you try to take the square root of -1, the real number answer is nan. This is short for not a number, just a little abbreviation, but it is a kind of number, a secret number that Java will return. You can't do anything with nan. You can't add nan to other values. You just get nan again. It stays not a number. It's like a virus that infects all other operations. But it is useful to actually have a value that you can test for, that you can check. Is this maybe nan? Is this value that I've put in this double box a nan? Because the alternative is to just stop the program. You try to take the square root of a negative number, either Java has to work with that value somehow, and it does that by using nan, or it needs to just blow up the computer, which would be really inconvenient if it's, say, flying a plane. Okay. But let's talk about this other whole chapter. that you've also read about, I hope, by now. Boolean. So I think I mentioned Boolean just quickly on Wednesday when I went through that table of types about the Java nodes. It's one of the basic types in Java. And to me, it's so natural that I just say it all the time: Boolean, 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 Boolean. But I realize, oh, don't plan your own. Where the hell are you? Play the whole thing, right? Okay. I think we can. Okay, good. Now it's going to play. I just say Boolean all the time because it's so natural. But I realize that to you it may be a foreign thing. So Boolean is a type. It's a type of box. It's a type of value. But when it's integers, the actual integers are infinite. 0, 1, 2, 3, 4 without n. 0, minus 1, minus 2, minus 3 without n. The infinite. Java can't store an infinite number of values. Infinite set of values. So it's integers in Java and longs and doubles and floats and charge and strings are all limited. There is a maximum integer you can store in int box. There are integers that are too big to put into an int box. There has to be a limit. Java is an odd language in the sense that that limit is part of the language. Java actually says the biggest number you can put in an int box is 2 to the 31 minus 1. No number can ever be bigger than that to fit in an int box. Other languages don't do that. They say there is the biggest number, but it depends on the computer you're running on. So if you're running on a smartphone, it will be one value, really big value. If you're running on a laptop, it will be a different value. If you're running on a different kind of laptop, it will be a different value. So other languages make a distinction between different hardware that they're running on, but Java doesn't. In any case, this is long story short to tell you that Booleans are an amazing type because they only have 2 values. You can only put one of 2 values inside a Boolean box. It can only be true or false. So it's like making a binary choice. Not like, it's exactly making a binary choice. A Boolean can only be true or false. Only those 2 values that it can store. There are loads of operations on Booleans. We have and, or, and not. And then we also have little abbreviations for them. So when I want to do an and on 2 Booleans, I'm going to say ampersand, ampersand, those 2 signs. If I want to do or, I'm going to put 2 bars, and not is an exclamation mark. So let's start with not because it's easiest. If I have a box, let's say A, and that contains a Boolean, I know it can either be true or false. And if I write an expression, not of A, Java is going to fetch A. And if A is false, then not A is going to be true. And if A is true, then not A is going to be false. So it just flips the value of A. Doesn't change the box. So A is a box containing a Boolean. I look inside, I see what is it. And if I write the expression not A, then I get a value, true or false, the opposite of A. If I say A equals not A, it'll take that flipped value and put it back into the A box. But if I'm not writing an assignment, in any other context, not A is just an expression. I can use it in many places. I can use it in assignments and loads of other places we'll see as well. Okay, right. So not is a unary operator. It only operates in one value, like the unary minus in mathematics. Minus 5 is minus 5. Only one value involved. But if I say 3 minus 5 or 6 plus 2, now I'm dealing with a binary operator that has 2 operands, 3 and the 2 or 5 and the 3. And in the same way, there are these 2 operators, and, or, sometimes we call them conjunction and disjunction. They operate on 2 values. So I've got an A and a B. If both are false, then A and B is false. So the and is really asking, is the first true and the second one true? And if either one is false, the answer is false. It's only true if both are true. So in this little table, if A is false and B is false, then the answer is false. A is false, B is true, the answer is false. A true, B false, answer is false. And it's only when both A and B are true that the final answer is also true. So A and B is asking, is A true and B true? And in the same way, A or B is asking, is either one true? Someone trying to come in the door. You look at the door. Someone comes in. They can come in. Walking away. On class. Maybe she shouldn't be at university. Who knows? Maybe she's just confused. Hungover probably. Okay, fine. A or B. So, is A true or B true? And the only case when it will be false is this first case where A is false and B is false. But if either one is true, the answer will be true. So I've got these operators. I can use them exactly like plus and minus. They only operate on Boolean values, but I can use them in expressions pretty much like I did before. I can write operations on integers, 5 plus 7. I can mix integers and doubles. So I can say 5 plus 7.3. And Java will say, well, now you're adding an integer to a real number, and the answer will be a real double. I cannot mix integers and Boolean. I cannot write true and 5. That's not allowed. So when I'm using these Boolean operators, the left-hand side and the right-hand side must both be Boolean. Not allowed to mix them. But how do Booleans interact with integers? Because sometimes you have integers that you want to somehow make Booleans. So there are these comparisons. I can ask things like, is this integer equal to this other integer? And the answer will be a Boolean. So before we had 2 plus 3, I'm adding 2 integers, and the answer is another integer. But now I'm comparing 2 integers or real or strings or what have you, and the answer will be a Boolean. So these are funny operators that send me back a value that's not of the type that it actually accepts, operates on. These are all very much standard. You've all seen them before. Only 3 things I must tell you about them. Firstly, less than or greater than work the same way, but when you write less than equal or greater than or equal, you must write the less than or greater than sign first. So it's less than or equal sign up here, and this order is important. And also you mustn't put a space in the middle, because then Java thinks it's 2 separate operators. You must write less than or equal. Do not separate them. It doesn't mean the same. It doesn't mean anything in Java if you separate them. Secondly, you can write not equal by writing a dot operator and equal sign or not. So exclamation character, exclamation mark, and an equal sign. Once again, they have to be next to each other, no spaces, and they have to be in that order. You can't write equals, bang, equals, exclamation mark. But bottom line is, not equality does what you think it does. It'll say, is 3 not equal to 2? It's not. So that's a true statement. Is typo on the slide. Oh man, that should be a not equal. Is 2 not equal to 2? No, 2 is equal to 2. So the answer to the question 2 not equal to 2, let's just pretend there's a... Okay, let's just pretend that's exclamation mark. The answer to the question 2 not equal to 2 is false. And the last thing is that equality is written with 2 equal signs. You must put both equal signs, put a space. It doesn't mean the same thing. If you put a space between 2 equal signs, you're now trying to write 2 assignments. That's not the same thing as asking if 2 things are equal. So all these operations will give me send back a Boolean. And at the moment, the only thing I can do with a Boolean is to put that in a Boolean box, a Boolean variable. On Monday, will start doing other things with Booleans. I kind of have to stop, but I will quickly go through these last 3 slides on Monday. All right. And bring chocolates. Chocolates, Monday.